Awesome. Well, hello. Welcome to our webinar for today. I hope everyone's having a great Thursday so far. My name is Heather Grant. I am one of the community admins in the maintenance community by Upkeep. Thank you once again for making the time to join us today. If you are not already a member of the maintenance community Slack group, we would love to have you join us. I will add the link in the chat in just a moment for the sign up. Today, we have Anna Goodman joining for a presentation on asset management effects on equipment health. I'm really excited and looking forward to learning a lot. The recording from our session today will be available actually right after we end our session at this link, as well as in the maintenance community on Slack tomorrow, along with a copy of the slides that you see here today. Anna is also available to answer questions in the Slack group, so please feel free to share the recording of this webinar or the invitation to Slack directly with friends or colleagues or anyone else you know who would benefit from hearing some of Anna's expertise. The final piece of housekeeping before we get started, you'll notice that your cameras and microphones are not turned on today. So what you'll want to do if you have any questions for Anna throughout the presentation is please use that chat feature on the right-hand side of your screen. Feel free to pop in and say hello, let us know where you're joining from as well. We will go through questions at the end of our presentation today, allowing Anna to kind of move through and flow through the presentation, and then we'll go ahead and have a little bit of time for questions and answers. But if for any reason we don't get to some of the questions, we will answer them offline in the community. That's all from me. Thank you again for being here, Anna especially, and I will turn it over to you to get started.
All right, thank you, Heather. Hello, everyone. My name, as you said, is Anna Goodman. I'm coming to you from Houston, Texas, and what we're going to discuss today is asset management effects on equipment health. A little bit about me to get us started. I am a mechanical engineer. I've worked in the nuclear industry, a sugar production facility, 2 plastic producing companies, one that produced copolymers and one that produced elastomers. And now I work in a HF production facility of Chemours. I'm experienced in reliability engineering consulting work. I've done some of that for some well-known companies, BP being among them. I enjoy working in maintenance departments to improve reliability and mechanical integrity programs, as well as improving the reliability of equipment. I have a certification in the API 580, API 510, and I hold a CMRP certification. I've trained in Apollo RCFA, and I'm experienced in FMEAs. And apparently there's a problem with my connection. Just one moment, let me refresh this page.
I can see and hear you fine, Anna.
Okay.
Yeah.
Okay, I'll keep going then.
Well, and now we're done. Hold on just a moment, everyone. We'll get her back in just a minute. In the meantime, we should be getting Anna back in just a minute, but oh, hello.
Hello.
Just as I said it, you dropped. Let's go ahead and maybe reshare screen.
Okay.
Sorry about that.
No worries.
The joy of live events. All right.
All right. So I think I left off with all of the acronym sections. And if anybody has any questions about what those are, I can let you know at the end. So I have previously held entry-level certifications in vibration, lubrication analysis, and thermal imaging. They're all predictive reliability technologies. And I've done a lot of data analyzing and determining bad actors and finding root causes in order to improve and optimize PMs. So that's kind of a little history about me. We'll get into the topic. So first and foremost, why is asset management important? The best decisions that can be made are well-informed ones. The more you know about a piece of equipment and how it operates, the better maintenance strategy can be created to ensure fewer surprises. Fewer surprises means a safer facility. So ultimately, asset management drills down and helps you with safety. The better the failure mode data the better the failure mode data that is taken on a piece of equipment, the more a site can manage to prepare for its inevitable failure. No piece of equipment is going to last forever, right? So knowing the nature of an asset also can help identify what condition-based monitoring can be implemented to have a more proactive and less reactive maintenance program for them. The better understood and document the design and process limitation data is for an asset, the better the caretakers can work to keep up with these the codes and standards during the life of service. So the codes and standards that I'm talking about here are the design codes as well as some of the testing codes. And it depends on whether or not you're talking about a fixed piece of equipment or a rotating piece of equipment. But there's a lot of standards out there, and we'll get into some of them while we dive deeper into this stuff. So when does asset management start? To me, asset management starts at inception. Design details must be documented and stored in a proper place, such as a database or a folder system. And these design details can be your design pressure limits, design temperature limits, material specifications, and codes of construction. Upon receipt of an asset, manufacturer recommendations should also be documented so that you can create better preventative maintenance strategies, predictive maintenance strategies. You'll be able to determine what spare parts you need in order to keep that piece of equipment healthy and working properly. And then the replacement type and frequency, all those recommendations are in your manufacturer manuals for a lot of your pieces of equipment as you get them in. So some examples of asset tracking in the modern world, it's all digital, right? You have Capstone, you have things like PCMS, you have SAP, access databases, procedures, Excel sheets, and document storing software such as SharePoint, WebTop, S Drive. These things can store all your details in a text format. They can also link things like PDFs and DWG files so that you can track and maintain, and it can be maintained as an evergreen process. If there's updates, you'll know where to go to update that information. So once the data is collected and organized for an asset baseline strategy for care and the preservation of the equipment, these strategies, you can make your strategies. And I keep talking about strategies because ultimately that's how it ties into reliability, right? So you have to have a plan in order to get ahead of the failure for your asset, therefore managing its equipment health. And you do that by, making sure that you consider all your failure modes and you're proactive as possible as well. So one example that I threw in here was a mythical peanut butter pump, right? So for a pump, you can have failure modes such as lubrication issues, alignment issues, seal issues. Your maintenance strategies may include oil changes, balancing and alignment, inspection and replacement. And then to be even more proactive, you're talking about your lubrication samples, your vibration readings, and your thermal imaging. And depending on your piece of equipment, of course, you can go down all kinds of rabbit holes of different technologies that may work better for that type of equipment. So to also improve your equipment health, you also need to pull in more data to make adjustments. So that's part of what applies to the evergreen part of this too, is not only do you have the initial data, but you also have the data that you're collecting during the life of your piece of equipment. So if it's failing, you don't just say failed, and when it's fixed, acceptable, okay, right? You want to try to document better what exactly failed, how it failed, maybe dig a little deeper, see if it could be prevented in the future, and then what was done to fix it. And if you document those things well enough, you can find trends with your equipment, and then you can make changes to your strategies, such as frequency, your replacement part scope, directives when the asset's open. Maybe you want to make sure that Every time it's opened, you inspect it to see what new things you can learn about it, and so, during for inspections. The key here is that the changes that should be made during the life of an asset should be backed up with the data and analysis of that data. So the more you can steer toward a condition-based program from a time-based program, the more proactive the reliability program at your facility can become with, again, fewer surprises. So what about when data is missing, right? This is all great and fun and theory, but application, we know that you definitely have some holes, right? And as reliability engineers, a lot of the time, and maintenance engineers, it comes to us, down to us to find out this data on these on the equipment that we are put in charge of. So to find missing data, you can find it in a few different ways. You can contact your vendor. A lot of vendors typically have manufacturing manuals for older pieces of equipment that you can get a copy of. If that doesn't work, verifying materials and dimensions in the field and establishing a current baseline can be a good starting point. Um, Also, engineers can assist with establishing appropriate threshold calculations. A lot of the limit recommendations and life projections can be done in that phase as well. Additional testing and inspections can be performed and documented to establish true condition. So not just a visual and a PMI, but you could also say, okay, we're going to do for like a piece of piping that we're unsure what the pipe specification is, right? You would want to figure out what kind of material and visually look at what the exterior looks like, but maybe also you would want to do like a UT to figure out how thick it is to figure out that remaining life, or an x-ray to see if there's any cracking in that section that needs to be taken care of before you run that section any longer. Also, training can be given to give the gatekeepers for better data collection moving forward in order to be able to confidently make judgment calls for strategy establishment and changes. My apologies. Plant personnel can also be a good resource to get a good feel for a good starting place for strategy building. And if these options prove not to get the results needed, the best practice is to rely on your rega gaps for guidance. So what are rega gaps? Rega gaps are recognized and generally accepted good engineering practices. OSHA has a definition here that I copied for your convenience, and there's a link as well if you want to dive a little deeper into this material. But basically, anything that's covered by PSM process must comply with REGAGAP. Inspections and tests are performed on these, and they're subject to mechanical integrity requirements. And that's not just for fixed equipment, that's for rotating equipment as well. And inspection and test frequency can follow your manufacturer's recommendations, these rega gaps, or can be dictated by your operating experience. So some examples of what a rega gap could be: equipment or asset dependent, right? It could be API codes, it could be ASME codes, ANSI codes, ISO codes. In the electrical world, the NFPA codes do a lot of the leading work in that. And then we just saw what OSHA says about the rega gap codes. So essentially, good asset management can help a site establish the best and most effective plans for maintaining equipment, therefore improving equipment health. A healthy and safe plant is a reliable one. That's all I have. Any questions, comments?
Awesome. I haven't seen any questions in the chat, but please feel free to send through. I'll have it as a resource here. I have one question that came up for me through this presentation, and that's kind of about this when does asset management start idea. So, your recommendation is at inception, which makes a lot of sense. But what kind of challenges or like difficulties have you seen? Maybe it's failures or is there anything else when you don't start asset management as inception? Kind of like what's the flip side there?
So the flip side of that is if you lose that design intel, and that design intel can really drive your frequencies as well as the technologies used during your maintenance tests and inspections. So one example of that I've run into many times in my career, many different industries, it's industry wide, is you have this vessel. The vessel has been in service for 30 years, right? But back in 30 years ago, no one was really as keeping track as well of like your U1s, which is the form that you get of all the design data and everything once it's purchased and on site and going into production. And that U1 dictates so many different design criteria and design um, details that then need to be implemented in your API program for your tests and inspections. And so it's hard to determine what kind of failure modes you have if you don't have that U1 to determine what your material is, what the initial thickness is, what your minimum thickness is. When should you be worried that this piece of equipment may develop a crack or a leak or a hole, or heaven forbid, completely rupture, things like that. If you don't keep that from the beginning, then you're basically having to reverse engineer your vessel in order to figure out what the best practice is moving forward.
Awesome. So it's kind of a combination of, you're flying blind. You won't really have all of the information to make educated decisions.
Right.
And then also you're setting yourself up for, more work in the future in order to kind of backtrack and capture all of that. Cool.
Yeah.
Really interesting. I actually have another question, and then the audience, please send any questions that you have as well. My other question is about this idea of evergreen process. I think obviously, documentation and setting up repeatable procedures is super important in a lot of different fields, but especially in this one. Who do you see as typically the owner of kind of driving that documentation effort within a maintenance team?
So within a maintenance team, a lot of the time it's the leadership that drives maintaining that evergreen process. So people like lead reliability engineers, lead maintenance engineers, maintenance managers, those kind of folks usually take care of the paperwork side, which is basically what the procedures are considered. And with the help, of course, of your production side, because they ultimately own the assets. But I have yet to run across a site where they don't have some kind of document management system. It's all about making sure the proper forms and approvals are gotten in order to keep them updated as you're improving things and as things are becoming obsolete and you're finding replacements and things of that nature.
Awesome. Well, I appreciate you answering my questions. As I mentioned, Anna is active in the maintenance community. So if you have any follow-up questions, feel free to reach out to her there or to me, and I'll redirect your questions to Anna. Thank you again for your presentation today, and to all of our attendees for making the time. I think we'll end it there.
Okay. Well, thank you for inviting me to talk. I know this topic can be a little on the drier side, but I think it's definitely important.
I agree. I think it's important, and I thought it was really interesting, kind of discussing how it affects the asset over its whole lifetime. So I appreciate you taking the time.
Thank
awesome.
you.
I'll see everyone next time. Thanks again.
Take care.
Bye-bye.
Bye.